Well, welcome back to our journey through stoichiometry and our calculations involving the mole. Hopefully you've had a bit of a go at the mass stoichiometry, so the working out one thing in equation, so the amount of product or reactant that'll form based on something else in the balanced equation. I've had a go at a few of those questions. If not, I recommend you go back and practice those questions because you're going to need to be able to do that for this. Okay, so let's think about this. When we're talking about limiting and excess reagents, we're talking about how much we'll get when something runs out. So I'm going to take you through a little bit of an analogy first, and we're going to talk about making sandwiches. Okay, so let's think we're making ham sandwiches, and let's not make it complicated. These sandwiches are going to be very, very simple. We are only going to use bread and ham, and therefore we can write a simple chemical equation. So ham plus bread is going to equal a ham sandwich. So if we have some ham, we have some bread, we can make a ham sandwich. Okay, nothing else, just ham and bread. So if we think of this like we think of it a reaction, and we say we need one slice of ham and two slices of bread, so just one slice of ham and two slices of bread, they become like our coefficients in our reaction. Okay, and then we would only form one sandwich. Okay, so we get one ham, two bread, and we get one ham sandwich. Okay, if we don't have at least one piece of ham, okay, and two pieces of bread, then we can't make a sandwich. We have something other than what a sandwich is. Okay, so let's think about this. If we had three pieces of ham, okay, and some bread, then we can make three sandwiches if we had enough bread to make it. If we had 18 slices of bread, how many sandwiches could we make? Hopefully you come up with the answer 9. Okay, so I will get half the amount of sandwiches as slices of bread that I have. I will get the same amount of sandwiches as slices of ham that I have, as long as I have enough of each of the other components. So if we had 5 pieces of ham and 4 slices of bread, so we're saying we have 5 ham and 4 bread, how many sandwiches could we make? Well, hopefully you realize that we will run out of bread before we run out of ham. Okay, so we're going to be able to make 2 sandwiches from the bread that we have, but we would still have ham left over. So we'd get 2 sandwiches and we would have 3 slices of ham left over. Okay, so we would have our 2 sandwiches and then 3 leftover ham. So this brings us to the idea that we want. In this example, bread is what we refer to as the limiting factor or the limiting reagent. It's the thing that runs out first. Okay, so our limiting factor is going to be the reactant that runs out first. Okay, so in this example, we will run out of bread and have leftover ham. Because we have leftover, we refer to the ham as being in excess. So this is the reactant that we have more than needed. Okay, we will have leftover. Okay, so let's have a look at this. So now we've got 5 pieces of ham and a whole loaf of bread, which is 16 slices. How many sandwiches are we going to make? Well, if I've got 5 pieces of ham and I've got bread, I know that I need 2 slices of bread for every 1 piece of ham. Okay, so if I'm going to use up 5 pieces of ham, I will use 5 times 2 pieces of bread, which is going to equal 10. And hopefully that makes you realize that we'll be able to make all 5 sandwiches, but we will have 6 slices of bread left over. So in this example, our ham is the limiting factor and our bread would be the excess reagent. Okay. Let's go through Big Macs fairly quickly. It just shows some different ratios. So if we look at this, we've got 2 all beef patties, special sauce, cheese, pickles, onions, all on a sesame seed bun. Well, we're not going to do all of that, but essentially the main components of a Big Mac are the patties and the bun. Okay, so if we look at the beef plus the bun, we're going to get a Big Mac. Okay, and we've got 1 piece of beef and then the 3 slices of bun. Okay, so we know that we need 2 all beef patties and we need 3 pieces of bun to get our Big Mac. So this is changing the coefficients in front of our species in our reaction. Okay, so if we have a look at this, if we have 10 beef patties, okay, 9 pieces of bun, how many Big Macs can we make? Well, I've got 9 pieces of bun. I need 3 for each of those, so I'm only going to be able to make 3 from the bun, and I'm going to be able to have 5 from the beef. Well, this is going to be my limiting factor, so we're only going to make 3 Big Macs. Okay, even though we have 10 beef patties, we don't have enough to make 5 Big Macs worth of bread. Okay, so in this case, our bun is the limiting factor, and our beef is in excess. Okay, this all seems kind of crazy, but just run with it for a little bit. Okay, so if we have 111 pieces of bun and 64 beef patties, how many Big Macs are we going to be able to make and sell? Hopefully you came up with 32, because we will divide this by 2, and 3 lots of that is going to be 96, and we have more than enough bread for that. Okay, so that gives us... we don't have enough for 37 Big Macs, so we can make 32, and we'll be left with 15 pieces of bun left over. Okay, so in this case, our beef is the limiting factor. It's the one that runs out first, and our bun is in excess. Okay, let's apply this to some chemistry rather than just making burgers and sandwiches. Okay, so if we perform a reaction, usually we will have a given amount in mass, volume, mole, doesn't matter what we're measuring it in, of all of the reactants. That's how much has been put into the flask. Usually one of these reactants will run out before the other. Okay, so it will limit the amount of product that is formed, and the other will be in excess. So the one that runs out first is going to be our limiting reagent. The one that we have left over is our excess. So if we look at this equation for the Haber process, the production of ammonia, we can see that 1 mole of nitrogen will react with 3 moles of hydrogen, and it will produce 2 moles of ammonia gas. Okay, so if I had 1 mole of nitrogen and 4 moles of hydrogen, okay, then all the nitrogen will be used up, but I will only use 3 of the hydrogen, so I would actually be left with 1 mole of hydrogen left over because it's in excess. Okay, so it would stay in the flask and it'd just be hanging out, it'd be in excess. Okay, so we would have this left over 1 of hydrogen. So this is a graphically way of representing it. So this is my nitrogen. These are the 3 hydrogens. They go together to form, they're going to react, okay? And we are going to react here, get our product here. So these are representative of moles, not atoms. So this is our 4 mole of hydrogen. So we've got our 1 mole of nitrogen, 3 moles of hydrogen here, and then this leftover one here. Okay, so what is the limiting reactant in this process? Nitrogen gas, and in excess we had hydrogen gas. It is important, you need to be able to identify limiting reactants in equations, and you will often be asked what the limiting reactant is and what the excess reagent is, so it's important to get this vocabulary straight. So how do we work them out? Let's look at a sample problem. So if we're going to determine the limiting reactant, to calculate the mass of the product formed in a chemical reaction. So if it makes sense that if the limiting reagent is the one that runs out first, it is the one that the amount of product we get is dependent on. So anytime we want to work out the amount of product in a reaction, we always need to see if we've got a limiting reagent. Okay, so let's have a look at this problem. Magnesium and oxygen react to form magnesium oxide according to the following equation. Hopefully this looks familiar. It's one that you did the other day in prac. So if we take 6 grams of magnesium and 2 grams of oxygen, okay, this is what's available for the reaction. Determine the limiting reactant. the reactant in excess and by how many mole it is in excess of. And then it also wants us to find out the mass of magnesium oxide that is formed. Okay, so let's have a look. One good thing is always to collect our information. So if we say that we have 6.00 grams of magnesium here, 2.00 grams of magnesium here, and hopefully what you've realized is that we have a mass for both our reactants. So when we were doing mass stoichiometry, we were always missing one. Okay, we didn't have both. So anytime we have a mass or an ability to find a mole of both reactants in a reaction, it should tell us that it's going to be a limiting and excess problem. Okay, so the first thing you should be doing then is actually working out the mole of each of them. Okay, so we want to convert the mole into mole for each of the pieces of information that we've been given. We were given a mass, so we're going to use our N is equal to M divided by MR formula. We're going to take our 6 grams, divide by 24.3, remembering that this is the molar mass of magnesium, which we got from the periodic table. And when you do that calculation, you should end up with 0.247 mole. We do the same for oxygen, okay? And we can see here that we get 0.0625 mole. Okay, that's great. We've got the mole for both of them. Now what do we do? Step 2, compare this mole ratio with the mole ratio in the question. Okay, so according to the question, 2 mole of magnesium will react with 1 mole of oxygen because we had 2 Mg plus O2 going to 2 MgO. So we can see that we've got a 2:1 ratio. So if we set up the ratio grid, okay, we can see this way that we've got a 2:1 ratio. We have 0.247 mole of magnesium, so we're going to work with that. Okay, we're going to forget that we know how much oxygen is actually there, and we're going to pretend like we don't know and work out how much oxygen we would need to react with that amount of magnesium. So we're going to do some mass stoichiometry. So if we set up our grid, okay, so we've got the mass of magnesium, mass of oxygen, it's 2:1, number of mole, and this of course is our X value. If we cross multiply, we will get 2x is equal to 0.247. If we divide that by 2, we will get the fact that we require 0.124 mole of oxygen. Okay, so from this, what we're working out is O2 required, okay, to react with the amount of magnesium that we had. So if you remember, we actually calculated how much magnesium we had. So if 0.247 mole of magnesium were to react, it would need 0.124 mole of oxygen. Okay, if we go all the way back to step 1, you will see that when we calculated it, we only had, all the way back here, we only had 0.0625 mole of oxygen. Okay, so we calculated that. That's how much we actually have in the flask. So in that case, if we look at this, 0.063, which is what we have, is less than 0.124, okay, which means that oxygen must be the limiting reagent. I don't have as much as I need to make all the magnesium react, which means that the reaction will only proceed for as much oxygen as we have. So, because we know that oxygen is now limiting, we want to work out how much magnesium is in excess because it was the excess reactant. We can use our mole ratios again to calculate the amount of magnesium. Okay, so we set up our ratio. We know that magnesium is 2:1. We have the number of mole of oxygen that will react this time. So this was based on my limiting number of mole. Okay, and we can see that using our cross multiply again, we will find that 0.126 mole of magnesium will react. Okay, and only that, because after that we've run out of oxygen. Okay, so if 0.126 mole of magnesium reacts, we have 0.247 in the reaction vessel, so we subtract them. So 0.247 minus 0.126, and we will see that we get 0.121 mole, and this is what will be left over. Okay, so in our flask, we will have magnesium oxide that was formed and the leftover magnesium, both in our reaction vessel. Okay, so we've now worked out which was limiting, which was excess, and by how much the excess reagent was in excess. The last bit of our question said find out the mass of the product that was formed. Okay, anytime we want to find out the amount of product formed, we have to use the limiting reactant because this is the one that's going to run out first. So if we set up the ratio to find the number of moles of the product formed, we will always use the limiting reactant, set up our reaction grid, cross multiply, and we will see that we will need to the mole of magnesium oxide is going to be 2 times the mole of oxygen, so we will actually get 0.126 mole of magnesium oxide being formed. If you're doing it by the what you want over what you know method, this will still work for these. Okay, in this case, what we know is 1, what we want is 2, so if we're multiplying by want over know, if we go back to the original equation, we would end up with multiplying by a factor of what we want, which is magnesium oxide, because we're looking for the amount of product, and then what we know is a factor of 1. So same maths happening here. We'd be multiplying the number of mole by 2 to get 0.126 mole of magnesium oxide. The question asked us for mass though, so essentially what we need to do from there is we're going to use our N is equal to M on MR formula, rearrange for mass. We get 0.126 mole multiplied by 40.3, giving us 5.077 grams is the amount of product that we would expect to produce. Okay, so in the reaction of 6 grams of magnesium and 2 grams of oxygen, oxygen is the limiting reactant, magnesium is in excess by 0.121 mole, and 5.08 grams of magnesium product is produced. This would be a really big question on an exam, okay, so you would be expecting it to be worth quite a few marks. Here's another one for you to have a go. Okay, this one is looking at carbon and silicon dioxide reacting together. You have been told that you have 40 grams of carbon, 40 grams of silicon dioxide. They're placed in a furnace and you need to work out which is the limiting reactant, which one is in excess and by what amount, and what is the maximum mass of silicon carbide that can be produced, remembering that this must be calculated from, this one here must be calculated from the limiting reactant. Okay, calculate from the limiting reactant. We said that if we have the ability to calculate 2 number of mole, we should. So 40 grams of carbon, we're going to find N for this. We're going to find N for silicon dioxide. Ignore that you have one of them and then use stoichiometry to work out how much of the other would be needed. Have a go at that. Okay, a bit of practice, and I will put some work solutions up online for you to be able to have a look at to check your answers. Okay, and then you've got another practice question here. It's for aluminium and iodine reacting according to this equation. Okay, always double check that your equations are balanced, and then you're going to check what mass of aluminium iodide would be formed when we have 1.350 grams of aluminium and 2.354 grams of iodine. Same process, give it a go, and good luck. I'll put up a couple more videos from Tyler DeWitt. He's got some great videos on limiting and excess problems as well. Remember, you can email me if you've got any questions, and good luck.